We'll jump into our next topic, which is data types and logic. So there's a number of different data types that you'll see within Apex. And these are the general classifications. You got primitives, you got enumerated lists. There are S-objects, whether it's the S-object parent or the concrete implementations of S-object. There are three different types of collections. There are both system classes and custom classes that you create. Those are typed. Null is also considered its own type. The Apex primitive values, you can think of them as being passed by value, and you can think of your object instances as being passed by reference. Technically, the primitives are passed by reference, but they are immutable. So what that means, for those of you who've worked with, for instance, strings in Java, you're technically passing a reference, not a copy, to, for instance, let's say a method. But if you make a modification to that value, it then creates a new copy in memory, and the original reference is unchanged. So technically it's not passed by value, but it tends to behave similar to that. Okay, so if you want the example, it behaves. Primitives in Apex behave the same way as strings in Java. They are immutable, they are unchangeable, and therefore it creates a new copy. Other non-primitives are passed by reference, much like you would assume them to be. What are the basic primitive data types? Well, you got Boolean, you got your date and your timestamps. There is ID. ID is implicitly convertible into strings and vice versa. ID is a very important data type in Salesforce because it represents the primary keys, and also, for that matter, the foreign keys of the records within the Salesforce database. Okay. Integer, long, double, and decimal are different forms of numbers. String, binary, large, object block, and then object. So what's object? Well, object is the parent to all of these primitives. So if you were to, let's say, have a method in which you don't know whether you're going to be passed a string or a number, you could declare the data type of the parameter as being object, and then since that's the parent class, it could work with either. Okay, so at the end of the day, object is the parent to all of these other data types, all these other primitive data types. Enumerated lists, so we can work with enumerated lists within Apex. So we can have a predefined set of, for instance, in this case, all the different seasons and perform comparisons. You'll see these used in things like status codes throughout the product, logging levels. The S-object data type, another extremely important data type. So first off, there's a parent class called S-object, and S-object stands for Salesforce object. Okay? Whether it's a standard object like an account or a custom object like a position, all of them extend S-object. All right. So here we are with some code working with an S-object. Account A equals new account. We can use dot notation to access field values. There's also this ability, notice down here it says name equals Acme. This gives you the ability to, in the constructor, set values, and then you can do the same thing with custom objects. There's a key reason, or there's a key capability of using the initialization in the constructor, using line 3, in other words, as opposed to line 2. One of the key advantages to line 3 is that you can initialize the value of an ID in that key value pair constructor Once you've instantiated an S object, you cannot reset the ID or set the ID, okay? So once you've instantiated it, you cannot say a.id equals this. But when you initialize it, you can say, you know, new account ID equals X, okay? So it's just one of the capabilities you gain, one of the advantages, or the advantage of using the key value pair as opposed to the dot notation for fields. Okay? All right.
So you can pass multiple, right?
Yes, you can also have multiple values, just comma delimit them. So if you wanted to do both ID and name, just do name equals this, comma, ID equals that. So, yeah.
Why would you want an ID to be set? Isn't that something system generated?
So another key thing to understand about when we're thinking about working with data in Apex, we're you know, when I have an instance, like on line 1, I have account A equals new account. A represents a record. It's an in-memory representation of what will ultimately be a record, okay? Now, we are still on the application server. So when we're executing our Apex code, we're in the application server operating in memory on these representations of these records. So when we initialize the ID to equal something, think of it as an in-memory representation of that record, but it's not setting it in the database, okay? So why would we want to do that? Well, let me give you an example. Let's say that I have a job application, and the job application has a associated position record, okay? I can instantiate a position record taking the position ID off of the job application, and I can create an instance of a, you know, an in-memory instance representation of a position record and say take the position ID from the job application and then use that to instantiate that copy of that position record.
I suppose, but I just always thought ID was a unique
It is.
key identifier that
It is.
You know, you
So
can really play around with.
So, well, you're not playing around with it. Now that you've initialized the ID on this new position record, now you can perform an update on it. So let's say I need to change the status of my position. So I need to change a field value. Now I have an in-memory representation of that record. I then perform an update on that position record. It then locates that record based on its ID in the database and performs the update to the other field. I'm not changing the value of the ID field. So if I, you know, understand that let's take a look at line 3. Line 3 does nothing to the database. Okay, it's not until I say insert or update that I'm going to reach out to that database and modify a row in the database. All of this is in-memory operations operating on the application server. Okay? All right. All right. Here we have an example of working with the S-object data type. What we're showing you here, where it says S-object S equals new account, you know, let's pretend for a second that this was a parameter in a method. Maybe we have a generic method that works with any type of record. Normally, if you're going to write line 1, you're just going to say account, you know, account A equals new account. But if it's a parameter within a method, then you possibly don't know what will be passed to you. So you declare the data type as S-object. You can use the put and the get methods to either set field values or access field values without knowing the underlying data type of the record. So for instance here, I am passed a reference to an account. I then say I want to set the name field equal to salesforce.com. Down here, we can get the value of the name by doing s.get name. What this means is that you can create flexible code where you may not know the data type of the records that you're working with. Okay? Why would you do this? Well, the reason you would do this is maybe you want to have generic exception handling logic. You want to have generic logging logic. You want to have something that generically works with DML, so it's going to be updating, whatever it is in the database, but you have some default logic, reusable logic that you want to use. Okay? So the key thing to understand is we don't need to know the concrete data type of the record that we're working with to either access or to update that record. We track things like fields. So if you attempt to delete a field and your code is referencing that field, it'll prevent you from deleting that field. It'll say, I'm not going to let you delete this field because this Apex trigger is referencing this field. What it's doing is across the application server and the database tier, it's actually checking the consistency to make sure that you don't cause yourself a runtime exception because you deleted something that's being referenced on the other tier. Working with the generic SObject type, you can set the type to be SObject. You can use casting nomenclature to cast it back into account like we see on line 2. So there are 3 types of collections. There are lists, sets, and maps. A list is an ordered collection of anything. A set is an unordered collection of unique primitives or SObjects. And then a map is unique keys to values which are non-unique, can be anything. Okay? So let me walk you through these 3 different data types. With a list, essentially it's ordered. So first item on the list is 0, and then 1, 2, and 3. The values can be anything, well, according to whatever the data type is, but you can set the data type for the values to be whatever you want. Here we have an example of a list of strings. So here is my data type. We use the generics syntax in order to set the data type. So here is a list of strings, like so. Notice that it's non-unique, so we have staylor in there twice. There's a bunch of different methods that we can use to work with our list. So we can add, I'll show you a list of all these methods. We can add, we can check the size, we can get and set values at certain locations. There are no arrays in Apex, but you can use array syntax to work with lists. Okay? So unlike in another language like Java, where you have the concept of an array is different than the concept of an array list, at the end of the day, Salesforce has lists, and you can use array syntax with those lists. Okay? So it's just a coding shortcut. Don't read into it. Here are some of the different methods which are available to us. You can have lists of lists. You can have lists of sets. You can go 5 levels deep, so multi-dimensional collections. All right, sets. Sets are unordered collections of values which must be unique. Okay? So here's our notation. Set data type equals new set of whatever it may be. This one's a set of, looks like integers. You can add elements to it. They must be unique, but if you add something that's already on the set, it doesn't complain. It just says, oh, if there's already 47, then hey, there's already 47 on there. So here are the different methods which are available. Okay. A map is a unique key being mapped to a non-unique value. So here we have a map of strings to strings, and we have all our different colors and then the different values associated with those. Okay. And then here are our different methods. one of the things that people often are working with is to get all of the keys. In that case, we would call a method called keySet, which returns a set of all of the keys. We can also obtain a list of all of the values. That method is called values. And so if you do need to break it apart into a different structure, you can do that. Those are the three types of collections that exist in Apex. Okay. All right. All right, I'm going to very quickly go through logic, since you're all probably pretty familiar with our logic. The if-else. Hopefully everyone's familiar with if-else. All right, you can do else-ifs. Strangely, or for reasons I don't quite understand, there is no switch or case statement. Okay? So you do else-if, else-if, else-if. Okay? Do while, for loops. There's a break and a continue keyword associated with all of these loops. Same meaning. Do while has the exit condition at the end, and a while loop has the exit condition at the beginning. There's what I call the old school for statement. So you initialize, you have your exit condition, you increment or decrement for that matter. And then there's the for each statement. In the for each statement, you have something like a list or a set, and you say, all right, for each member of this, let's iterate over that list or set, and let's do something with it. Okay? So, all right, what are the different data types for Apex variables? What are some of the ones that we talked about? So those are all examples of what? Primitives. Primitives, very good. S objects, very good.
None.
Sorry?
None.
Null, okay. I'll take that. Yeah. Collections, very good. What about data types that you might create on your own? Custom classes. So if you create your own classes, that's a data type. All right. Enumerated lists is another one. So what are the three different types of collections? So what are the three different types of collections? List, map, and set. So who can tell me what is a list? Ordered. Yeah, it's an ordered collection of anything. Yeah. Not unique. Not unique. A set is an unordered collection of unique values. And then a map is where we have keys to values. The keys are unique, the values are non-unique. Very good. What are the different kinds of loops? Describe their syntax. While loop, very good. For loop, do while. Awesome, yeah. And there's two types of for loops. The for each, and then the old school, define your initialize, yeah. For integer I, increment, exit. Okay.